Good morning, everybody. Welcome back. Hope everybody is well. What I'd like to do today, as we dive in, I'm going to postpone our regular chat for just a little bit. So the topic I want to do is what science do we buy? And we will do that in just a little bit. But there's two things I wanted to do before that. Secondly, I'm going to work backwards here. Secondly, I just want to cover the bit at the end of last week's topic that we had to rush through, because it's kind of important in terms of our thinking about the relationship between science and scientists and policy and politics. Gives us a nice framing device for thinking about the types of scientists that exist and the approaches to giving policy and politics advice. We covered that in like 2 or 3 minutes at the very end of the course last week. I had to run off, my apologies. But it would be something that is quite useful to come back to. So we'll come back to that in a sec. Before that, I just wanted to jump in. It's now, this is the second last of the tools lectures. So next week we'll be going to a class on persuasion, and then after that we'll be diving in with the assessment periods where we look at the different topics. So what I just wanted to do is does anyone have any quick questions on the assessment? We will cover a lot more next week, but are there things anyone is wondering that you just wanted to ask now that might help frame the conversation for next week and the week after? If there are none, that's quite all right. Okay, cool. Don't stress it. We can obviously have a conversation at the end of this class, but next week we'll be able to cover a lot of the stuff that will be about, okay, what sorts of things will you be writing? What is an opinion piece? How to structure an opinion piece? What we'll be looking for in the assessment. So don't stress about it now. I just thought if there were things that you're wondering, we could do that. So where I want to go to start with is to finish off the end of the class last week. And the conversation I just want to have centers on an analogy that I find quite useful in terms of thinking about science advice, or the advice that a scientist might provide to someone looking for advice, a politician, a policymaker, someone in that sort of mix. But it also could be anyone, really, in terms of thinking about making decisions based on science. So I started this and went through very quickly. But what I'd like to ask, and this is a useful way of starting to think about how we consider science advice, is how do you provide advice to someone who might be new to town, and this is not in a COVID world, this is the world of normal times. What restaurant would you recommend to them? How do you recommend a restaurant to them? And this gives us a nice idea of the different sorts of advice that a scientist might give. Now, what I'm going to do is segment this advice on these two axes. Now, they use quite formal sorts of words here, but I will explain them, and the examples will help a fair bit. So on the horizontal axis there, the x-axis, I've got reactive to proactive. So in this contextualization, reactive is very much responding to the questions, the needs, the desires, the values of the questioner, of the decision maker. So here, this might be the politician says, hey, scientist, tell me this, and the scientist will react. On the other end of the x-axis are proactive responses, where a scientist is instead getting in front, trying to suggest things before the decision maker has necessarily thought of them. Now, there are times for both of these. This is not to say all scientists should be in one quadrant here out of the 4, or all the science should be in one quadrant. But there are times when a scientist should be reactive, and there are times when scientists probably should be proactive. And it'll make more sense when we get to the actual examples. On the y-axis, we go from contextual to myopic. Contextual, I would suggest, means fitting information in, the particular information that a scientist might have or hold or understand, in with a whole bunch of other information. Myopic means focusing just on the details that scientist knows. So if that scientist is a molecular chemist, then they will just provide whatever information is about molecular chemistry. If they are contextual, then they might say, yeah, I'm a molecular chemist, but I know that next to me, there are some people doing some other forms of chemistry. There are some people doing some ecological engineering, all sorts of things like that, that maybe we need to gather in their sorts of knowledge as well. And again, there are times and places for both myopic or contextual sorts of responses. So we can bring this back to the idea of the restaurant. If we start off and we think about the idea of the restaurant, the pure scientist. Now, the pure scientist, these labels, these all come from Roger Pielke's The Honest Broker, which is kind of worth a read, but I don't love it. But it's got some interesting things in here. And this quadrant is very much his work, and it's quite useful thinking here. So the pure scientist is that classic definition of a scientist who focuses just on their own domain and just on responding to the questions of the decision maker. In this, what might a pure scientist say if you ask what restaurant to go to? Any guesses?
The one they go to?
You could be the one they go to. Yes. What else might they be focused just on?
The one they think is the best?
Yeah. Can we narrow down? What might be their decision?
Their reviews, like
reviews.
Yeah, so data on which restaurant has been given the most, stars or something.
Okay. Yep, they could do that. Yep.
As somebody who's involved in food safety, I say this is the one that had the least food poisoning incident. I'd like you to go to that one.
Excellent. There we go, Raina. So what we're getting, and these are all actually myopic sorts of views. So a myopic pure scientist could just say, okay, I've looked at the reviews, and here's the one that's got the best reviews. Go to that one. Or they might say, I've done all the food safety, and I know that the safest restaurant in Canberra is this one. Just go to that one. Alternately, you could imagine other forms of restaurant type advice. They might look just at the dietary profile, or they might look just at one form of information. Basically, this is one form of information and saying, you should make your decision based on this. This one has the best reviews. This one is the safest. This one has the best dietary profile. And the point being here that the pure scientist, theoretically at least, doesn't tend to care about any other forms of information. Not necessarily saying they dismiss it, but it's not their job. Not their job to weave in these other forms of information. Yeah, empirical data says this. The science arbiter as well is still down the reactive end. So again, this is responding to the decision maker saying, okay, I want to go to a restaurant. But instead of just saying, okay, this one has the best food safety, or this one has the best reviews, they might respond to the sorts of questions that the decision maker might ask. So the decision maker might ask things like, I've got there, where is the nearest Indian restaurant? Which restaurants are vegetarian? But in all of this, it's providing information that could be data-driven or science-driven, but it's very much responding to the questions that that person has. You can imagine stepping up to a problem that's a little bit more complex than what restaurant do I go to, but you can imagine going to, how do we solve the pollution in this river? Where the pure scientist might just say, okay, I can only measure whatever that chemical is, and that's it. The science arbiter will say, okay, you ask me questions, and I'll see how we can find out there. We might connect with other people. We might merge different forms of information. But in all that we're doing, they're being reactive to the needs of the decision maker. Okay, how might the issue advocate, someone who is myopic but proactive, how would they recommend a restaurant?
They'd be like, hey, I know you like Chinese food, so here's the best Chinese restaurant based on reviews near you.
They would say part of that. So they are being proactive. I know, but the I know you like is not necessarily what an issue advocate does. Issue advocates are not always so interested in other people's values that much. They are a little bit.
They might say something like, Indian vegetarian food is the best food. So, you need to go to this restaurant here.
Yeah, yeah. Indian vegetarian food is the best food, and you can imagine a scientific restaurant version of this. You might go, an issue advocate says, okay, well, vegetarian food, vegan food has the lowest impact on the planet, so you should go to this restaurant. So not actually so concerned with the values of the restaurant decision maker, but more concerned perhaps with their own values or with pushing for a particular sort of outcome, for saying, oh, this is where you should go. This is, you know, I'm going to ignore other forms of advice. So again, this is on the myopic sort of spectrum. They are focused on one thing, where the pure scientist might be focused on one method or one type of data. The issue advocate is focused on potentially one sort of outcome. Now, the issue advocate is the one of here, and we'll come to one more in a second, that sits perhaps the most awkward with scientists. A traditional scientist will say, cool, I love being a pure scientist. I can just speak from my data. Or a science arbiter, I can at least say, you know, here's the other sorts of science around, and we can contextualize things like that. But the issue advocate seems somewhat anathema to a whole lot of scientists. A lot of scientists say, it's not my job to go out and tell people what to care for. And so a lot of people say, okay, that's bad. That's an issue advocate is someone who is not doing science anymore. They are just pushing an agenda. But are there examples you can think of that maybe an issue advocate might be an important role in science?
Maybe pushing for climate change science?
Yes, yes. So whilst a lot of climate change advocacy has been clearly done by political advocates or you know, obviously people in the political spectrum, there has also been a lot of what we've done in climate science has been made possible because scientists have said, no, you need to pay attention to this. No, this is important. No, this is something that we should be doing here. So climate science is actually probably the clearest example of that blending between, okay, what should a scientist do? Should a scientist sit back and just say, I'm a pure scientist. I'll wait for the politician to ask me about if the climate is going to catastrophe. Politicians don't ask that unless you tell them to. Similarly, a science arbiter is never going to bring up climate change unless someone asks them. So a lot of climate scientists have over 100 years had to be in the proactive space. They've had to be more proactive and stepping forward and saying, hang on, you haven't asked about climate change. You should start caring about climate change. Some of them getting to this point of being an issue advocate where they're saying, you know what, let's drop everything and focus resolutely on climate change. There are difficulties with that. Often issue advocates, once scientists become issue advocates, then they're often abandoned by their colleagues. I don't know if that's fair or not. Maybe it is, but it's hard to remain a pure scientist once you have become an issue advocate, because you're stepping forward and saying what people should care about. So the final quadrant, and this is one of the reasons I don't like Pilkey's contextualization here, is there's too much of an adjective here in the terms honest broker. It feels a little bit too generous to this person. So this is the last quadrant. So these people are being less myopic, they're being contextual. They fit all sorts of knowledge together, but instead of being reactive like the science arbiter, waiting for the decision makers to ask questions, they are being proactive. They're stepping forward and saying, okay, here's a range of things that are happening right now, and here's what we should be thinking about. Here's what I would recommend you as politician, leader, start thinking about doing. So in this sense, what they might be doing in the restaurant scenario is trying to understand a little bit more about the values of the decision maker. So whereas the science arbiter, you can ask them questions. They're a little bit like Google. You can say, okay, where's the nearest Indian restaurant? What restaurant has the best reviews? Blah, blah, blah. The honest broker might say, once someone had said, oh, where should I go for dinner? The honest broker will say, okay, well, what do you like? What are you interested in doing? are you vegetarian? Do you want to go close? Do you want to have 5-star experience? Anything like that. So we'll attempt to clarify the values of the decision maker before moving on to provide information. The question that I think is important is, when would each be appropriate? When should scientists fulfill these roles? When should science fill these roles? As Mia's put there, it was Justin. When should scientists set the agenda? Is there an easy answer to that? I don't know if I'm asking a rhetorical question or not right now.
Do you want it to be rhetorical, or?
It depends. Maybe actually what I want is to put you in discussion groups and get you to choose, chat to each other and decide when are these appropriate and when are they inappropriate, and how should we react to scientists when they move into these different quadrants. So I'll give you 5 minutes in a discussion group. Chat to each other, decide, just grab those labels: pure scientist, issue advocate, science arbiter, honest broker, but keep the quadranting. Decide when they're appropriate. Yes, I did rhetorically ask if it was a rhetorical question, Raina. Decide when they're appropriate, and then we'll have a quick conversation about that afterwards. So I'll put you into groups. All right, 5 minutes, come back at 9:52.
I'll let Bruce too.
How do I join back? I accidentally got booted out.
Excellent. Welcome back. Thank you for that. So, reflections. What sorts of things did you talk about in terms of when each of those four were appropriate? Is the pure scientist ever or always or regularly appropriate?
Pure scientists are great for academic journals, Will.
and that's an important thing, isn't it?
As I've just found in doing my essay for population health, yes.
There you go. Good. Rainer?
Oops. Sorry, I had problem unmuting. What we sort of said at times when you talking to decision makers as a scientist, sometimes there's somebody with you who's got the advocacy role and you've got the pure scientist role of providing the neutral advice. And neutral advice is valued by people. So I think sometimes if you take the pure scientist role and people have, as it were, they're prepared to listen to the facts and you considered a neutral person, then that can be a very powerful thing. While if they feel if you got, as it were, skin in the game, they then think you're just saying that because blah. And I mean, in a way, this is the argument that's been used by climate skeptics that that the scientists have got skin in this game. So it's not about the science for them. It's about that they have a vested interest and that they have an advocacy role rather than presenting the science. So I think at times you have to be a bit careful how you play that card.
Yeah. So there's an interesting parallel here we can draw on. So Aristotle defined three, well actually four, but we'll skip the fourth. Four modes of rhetoric that are worth thinking about in terms of how people raise an argument. And scientists use some of these a lot and some of these not so much. The logos is the one that is most germane to science. Logos, logic. So the logic of an argument. And so you could raise that in a court of law or you can raise it in a scientific process. We use logic a lot in science and that's great. So logos is a great way of raising an argument. But the problem for the pure scientist, or not the problem, but pure scientists rest very heavily on the logos and one of the other two, but not the other. So that can be difficult to communicate with people that don't grapple with logic. The second form of rhetoric that is used, that people use, is the ethos. So that is the stuff that is around you. So your degrees, your university, the stuff that sits around you. Now here, a lot of pure scientists will hold on to being very correct in sort of scientific formats, but not stepping out, holding on to that ethos very strongly. The final form is the pathos, the emotion. Pure scientists will resist that enormously. They don't want to use that. It's a legitimate choice because what they don't want to do is give up on the rhetorical stance of being a pure scientist who is neutral according to decision makers. And that is a very valuable thing. It really is. And we shouldn't force scientists at any point to dive into to becoming an issue advocate or to becoming any of these other groups when either they're not comfortable or when science that we do need in decision-making processes, neutral scientists. So I think there's a lot of value there. When was it appropriate that people should be an issue advocate?
According to the health promotion course we're all doing, all the time, apparently.
All the time.
We were
So tell me tell me
sorry.
how. Yeah, tell us how that's okay in that context.
That you have to recognize that even if a disease or something seems to be like, yes, scientifically this is it still affects a person who exists in a society. So you need to look at all of those other things that are affecting them.
Mm-hmm.
And as much as you might think, well, I want to treat diabetes, you need to think, what are the lifestyle factors that affect diabetes? And you might find yourself advocating for nutrition or exercise or green spaces instead.
One of the really interesting things for me about public health promotion in general, but public health is a very strange scientific discipline because it's one of the very few scientific disciplines that is oriented directly towards politics. You just can't take it out. Whereas, a black hole scientist or a chemist, they can ignore politics. They need politics, as we'll come to in a little bit, to fund their lab. That's fine. But they very much don't need to engage with politics. But if you are a public health scientist, then some of your results will say very much, this political outcome is going to make people less healthy. This political outcome is going to make people more healthy. So they are engaged with the makeup of society and the politics more than any other discipline that I can think of, any other scientific discipline. So straight away, I would say, yes, public health are more proactive and potentially are more issue advocacy than a lot of other science disciplines. Susie?
That just dovetailed with what our group talked about, because we only managed to talk about issue advocacy in the 5 minutes. But we were talking about that exact thing, that if you are in a field, or if you're a scientist in a field that has political application, policy application, then maybe you'd find yourself in an issue advocacy role because advocacy itself makes sense.
Mm-hmm.
And the other thing that we talked about was around the nature of the primacy of the issue, like how important is the issue relative to other issues. So COVID-19 is a really obvious example where it's not that other issues are not important. It's that when COVID-19 is involved, COVID-19 becomes the most important issue because it then affects all other issues. And climate change is another example of something that's similar, but in a longer timeline. And so maybe it's a more appropriate to be an issue advocate for those issues because they have cascading effects onto everything.
Mm. Yeah, absolutely. I think that's a great point. But then, this is the role of the issue advocate sometimes, is if there is a small issue, one that hasn't transformed all of society, and you are the scientist who have seen it, you've been out there and you've discovered this species is dying, this river is polluted, this particular policy is causing people to die or become less healthy, then at some point you need to become an issue advocate. Otherwise, it's not going to happen. I don't know. I think there's a really interesting tension there. Mitchell.
So if you are a pure scientist who does want to dabble in issue advocacy, would you recommend perhaps developing a separate persona that is unidentifiable? So you're a street scientist, but then you put on face paint and a camp costume and you advocate for your issue. Is there a benefit to doing that?
Not really. I mean, look, I get the, the V for Vendetta. You put on a mask and suddenly you can become the hero that the world needs. But really what you are trading on, scientists have to trade on their credibility, and their credibility comes from the things they publish, the things they know, the things that they are. And I don't think you can you can't have it both ways. If you want to maintain your position as a pure scientist, then it is very, very hard for you to go out and say, we need to do this.
The point was, like, if it was an anonymous persona, that is, can you separate them to any extent? Or does that even risk your credibility? I guess it does.
It's probably worse if you get caught. Like I'd say the risks then of if it stuffs up and someone catches you, then guaranteed things will change more radically than if you had tried to walk a squeaky line between them. I'm sure there are people that do it.
So you're not recommending it? Okay.
When in doubt, I don't recommend. No, look, actually, there is a significant role for anonymity, but I think it's a tricky one. Mia.
Hoping you can hear me okay.
Yep.
Great. Okay. One of the questions, and it touches on this and also some of the other things that we've been learning about in this course about distilling message and focusing on audiences. So I wanted to ask, and it touches on credibility as well. When you have a topic, so I guess I'm relating it back to my own experience in animal welfare science, where I do sometimes feel like my role is advocating, but I also feel like I have to do a lot of tailoring my message to different audiences. But then I get concerned that credibility could be risked because I look inconsistent. Because sometimes it's enough of a message to explain to people, hey, we've learned a lot more about animals and how they can feel pain and suffer over the last 20 years. We should change the way that we treat them. And other times I have to couch my message in terms of there will be economic benefits to your program if you treat animals better, or you will see performance benefits in these working dogs if you treat them better, or you will have better staff satisfaction. And because with a different audience, I might focus on one message, but then those different audiences may all be in the same room. And so how do you remain credible and still lean on the evidence base, but have to try and jump through all these different hoops as a successful science communicator?
So it's not disingenuous to frame a piece of knowledge or a bag of knowledge, really, from different perspectives. And to say very much, you know, I can see your example here, you know, that there will be economic benefits to X. So here's a classic example from climate change. You can convince a climate denier to put solar panels on their roofs by talking about the economic benefits. You don't need to convince them of the import of moving away from fossil fuel power. Whereas you might convince a climate advocate, here's the best solution, go and get solar power. So the outcome is the same, but the framing that you have is very different. Now, as long as they're not disingenuous, as long as neither of them are untrue, then you're fine. And even if you're in the same room and you're saying, look, to you, I think what you know, it's really, you love your financial bottom line. Perhaps if you think about it this way, then this will be a result. And you love, you know, you're thinking about animal ethics, then you can do both, so long as they don't pull in alternate directions. You know, you can't say untruths. So you can't say this will make it cheaper, this will make it more expensive. You know, so long as people understand that they are multiple aspects of the thing, then that will be all right. So that's not issue advocacy, although I can understand how you could potentially slide closer to issue advocacy there. So I don't see the challenge there, but I think that is a big one where, you know, you're in a field where ethics is clear. Ethics is a huge component of it. I don't mean it's clear, I mean that it is there. It is very hard to bleed between the scientific elements of this and how do we deal with animals based on their ethics. I think it's a really challenging one.
I think probably similar to some environmental issues too, like the go-to rebuttal is, oh, you're a stark raving animal rights lunatic, or you're a stark raving greenie, and you just get pushed back and shoved away perhaps from industry stakeholders that have different backgrounds, different cultures, different takes on what good welfare or good environmental care is. So
here's what I would say then is that we all need to be aware of how any political or controversial topic, and this is what we'll come to in the second half of this course, is already framed. Like we can't step in there and go, okay, I'm going to reframe this entirely based on me. We have to recognize no matter what issue, there are already debates, there are already these sorts of positions and stakeholders. And at that point, when we emerge into it, we have to make a choice, or we have to think about strategically, are we going to be a pure scientist? Are we going to be an issue advocate? Or are we going to try and sit somewhere in the middle, you know, this honest broker or something like that? So I think we have to recognize that some fields will already be highly politicized, and therefore sitting as a scientist in there, maybe the only place you can be is a pure scientist, or maybe the only place you can be is an issue advocate. It depends on the topic. Rainer.
Yeah, I just wanted to add something out of my personal experience. I guess I'm still working in food regulation, where I'm a scientist. There's been huge effort over the years to separate the politics, and not just the politics, but the policy process from the science process in that area. Mm-hmm. The reason is that, for example, people use science as an excuse to put up trade barriers, or science as an excuse to get their own little personal deals through. And if there is no clear separation between the science and the politics and the advocacy, you find yourself in the role where your science or your viewpoints get hijacked and used in a way you're not going to like. So there is a case to be made to separate the science from the policy and the politics, and the whole public service pretty much works on that principle, and exactly for that reason.
Absolutely.
Saying that, there are times where you get a chance to speak up if something really, you think it's wrong, or there's an ethical problem with it, or something is going completely off the rails. I think you have the responsibility to then take on a role and speak out about that and be what they call frank and fearless. Now that's sort of fallen off the wagon a little bit, but it's really a question of calling it each time and deciding what you do. But the general routine process separates these things out, like risk assessment from risk management, policy from risk analysis, those sorts of things.
This is a really great point, Raina. That you know, we have barriers between these different groups for very legitimate decision-making reasons, and we will maintain a lot of those. I think they are very important. But one thing to throw in here is that if you're a pure scientist, you have to recognize that your job has been made for you by funding processes, decisions that have been made before you. So yes, whilst there is the trope of the pure curiosity-driven scientist, and we will come to that actually in this class in just a bit, who goes out, finds something new about the universe, and then says, "This is what we need to know." 99% of working scientists are framed towards problems that have been shaped by society, some very directly. If you're in government or if you're in a government research agency, then they have said, we need to find out more about this. You go and do it. We need to find out more about this. You go and do it. And so, are you a pure scientist if you have been told what to do all of a sudden? All right, let's pivot. We'll come back to those labels later on. They're very useful. The main thing that I think is useful are the axes, from myopic to contextual, reactive to proactive. Always useful in thinking about where should science and scientists sit. Now I'll just start my screen share. So what I want to explore now is the science that we buy. So the word buy, I assume, might sit a little bit strange for people. They might think, well, hang on, do we buy science? But of course, we do. We as a society spend a fair bit of money getting scientific outcomes. And those scientific outcomes are determined by, you know, the ways that we buy it and how we structure what we buy. So what I want to cover today is the process that we buy science here in Australia. It parallels enormously with most other countries, though there are, of course, differences. And some of the data has moved on a little bit, but it doesn't really matter in terms of the actual year to year. It's more thinking about the big picture of where do we buy science, how do we buy science, and what sort of outcomes does it lead to? So first question, anyone want to give a rough guess at how much Australia spends on science and research each year? I'll bring up the chat and I'll see who's got it in the chat. $10 billion from Mitchell, gets it straight away. There you go. Nice work. Did you look that up beforehand, Mitchell? It's probably a little bit more than that, but it's in that order of magnitude. It's certainly of the 10 billion ilk. It's much more than one, much less than 100. Varies a lot, and there's a lot of complication in how we classify it. And some governments will be increasing different amounts of that. So you might get 12, 13, 14, 15, 16 billion dollars. Other governments will be decreasing that $987 billion. But that's a rough approximation that gives us a pretty good idea of where we're at. Now, with that, do you think we're above average, below average, or on average for the OECD, for the developed countries? Below, 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 below. Well, except for Lauren here. Lauren's gone with above. How low can you go? Australia spends 10 billion on research, and we are pretty much about average. There will be years that we are below average, and there will be years that we're above average, but in general, we're pretty close to the OECD average of how much we should spend on research. The way of calculating that is as a percentage of GDP. Helen, I will answer that in a bit. Yes. So yes, this is government spending, but it's yes, we'll cover that more in a second. So you can see there are a couple of countries that are famed for very high research spend. South Korea is definitely one of the leading lights. Israel as well. They're both pushing close to 4% of GDP or 3.5% of GDP. Many countries are in the 2%-ish amount, but then there are clearly countries within the OECD here. So Italy is a little bit above 1%, China 1.5%. There is some variation in there, but 2% is about average there. Yes, Mitchell, 50% of countries spend below average in GDP. Obviously the width there are two metrics on that little graph there. Well, there's a few things. One is the percentage of GDP, is how far to the right they're going, South Korea at the top there. But then the other side is the amount they spend, which is based on how big your GDP is. So China and the US there, Japan as well, but China and the US have huge research spends just because the size of their economy is just so big. Now, as Zoe and Grace are just observing here, there is government spending and business spending. However, business spending is blended with government spending quite a lot. So we'll come to in just a second. There will be direct government spends, and then there will be something that is the business spend, which is basically still more government money. We'll come and explain that in a second. So what I want to look at is where this money goes. So this is a budget table from a couple of years ago here in Australia, and it accounts for where different research goes. Now, the first thing to look at are the grey lines. The grey lines are the big sectors in terms of Australian government research funding. So at the top section, Australian government research activities. We'll explain more in a second, but this is largely CSIRO and the Defence Science and Technology Group now, not organisation. And then Australian government R&D is different bits of money spent inside government departments. And so that out of the $10 billion, that's about $2 billion. So about a fifth of what's going on there. Next is the business enterprise sector. So this is about $3 billion. So a third of Australian government spend on research is actually business spending on research that government gives a tax break to, which can be a great thing. So a company decides to invest to build a new widget. Government has said this is a great thing for the economy. If you come up with a new innovation that delivers something for society, then we will fund that, not directly in terms of dollars, but by giving you a tax break in terms of the amount that you have spent on it. So this is not direct money. There are some quibbling about that because there have been things like, I think Gina Reinhardt's company had declared one of their new mines to be a research and development mine. I don't know, I guess you gotta work out how you develop a new mine. I'm not sure, but there you go. The next two sectors are fit somewhere in the middle. They're not as direct, and we'll come to this in a second. They're the higher education sector, which is made up of, the first bit there is Australian Research Council, which is a competitive funding scheme, and I'll come to what that is. Usually a bit less than $1 billion. Used to be Australia's major competitive research grant, but there are now things that are much bigger. Then there's the performance-based block funding, which is about $2 billion, which is largely an infrastructure grant for universities to do research. And that's basically funding PhD students, a lot of that. So again, about a fifth goes directly to universities to support them doing research via PhD students and things like that. The final are a couple of other competitive grant schemes, the National Health and Medical Research Council, the CRCs, the Rural Research and Development Council. All of that adds up to another 20% or so. This is just a pie chart because pie charts are terrible, but occasionally we should use them just to show what the slices of Australian research are. Now, the way that I want to split this in your minds is to think a little bit about a spectrum from directed research to open or guided research. So, yeah, we will do it this way. On the left-hand end, I've got directed research. Now, directed research might be those places where we use pure scientists, but this is where government is setting the agenda and deciding, okay, this is the question that we need answered. You go and do this. Typically, the dominant agencies that are doing directed research are CSIRO, Defence Science and Technology Group, or within government agencies. So this is the government saying, okay, we need to find out more about fish stocks in the Southern Ocean, or we need to understand more about what's a particular rust that is affecting Australia's wheat crops, or something like that. Saying to the scientists, the groups that are working there, you go out and solve this problem. At the opposite end, high level curiosity driven research. I've called it open research here, where it's the scientists that are deciding what the challenge is that they would like to solve. That means they might say, all right, I think the most important thing to solve here is, well, as our own Vice Chancellor Brian Schmidt won his Nobel Prize for working out equations about the heat death of the universe. And there is not a lot of government direction on that. You go out and do it, and you do what is curiosity-driven research. In the middle is more guided research, where you have funding bodies that are raising questions. They might say, okay, we need to have a bucket of money that is just looking at cancer, or in particular looking at certain types of cancer, or even more so looking at certain people with certain types of things. So rather than saying, okay, you go and literally solve this problem and this is how direct it will be, it might be, okay, there's a bucket of money to say, can you solve this problem? And we'll see if there's 3 or 4 different approaches. We might fund a few of those. I'll talk more about blue sky versus applied in a sec, but those are different labels. Blue sky is a common label that people use to talk about curiosity-driven research, open-ended research, looking at the big picture. Applied research is something that is more focused on solving a particular problem. But in saying that, there is a lot of blue sky research in applied. So we'll come through some examples of each type of research, and we can sort of get a feel for when they're used and when they're appropriate. So this is a few years ago. See, these are Department of Defence. So this is the Defence Science and Technology Group. These are research to fund to stop cyber attacks. Don't know how well that worked out. We're still getting a lot of those, or something on bioterrorism, or science redefining military physical employment standards. So these are all very much the Defence Department saying, okay, these are challenges that we are facing and we need to deal with. Similarly, CSIRO will be not focused on defence challenges, but on challenges for Australian environment or Australian farmers or industry groups. Weeds on Lord Howe Island, or supersonic tech to deliver low-cost magnesium. There you go. Or a sleep disorder startup. So these have all come from direct questions, or from either from industry or government, that CSIRO has been working on. At the other end, you tend to see more open research at the universities. Universities, because curiosity-driven research is a big part of what we do, tend to do more research that is at the other end. But there is a huge parallel. So, for example, warmer climate could lower dengue risk is an ANU project from a couple of years ago, could easily have been done at CSIRO as well. So there is significant overlap between both open and directed research here. New material to inspire lightweight planes and cars. Clearly, even though these researchers may be driven by curiosity-driven research, they're asking questions that have industry stakeholders and outside bodies in mind. Any questions on that? Now then, I have a challenge for you. What I'd like you to do is play around a little bit with, I don't know why, hang on, let's fix this. I don't know why I make it 1 billion. It should be 10 billion because that's what it is. Roughly $10 billion. Yeah, I know, it's Terry Mary, isn't it? What I'd like you to do is have a think about how you would give out Australia's research money. Now, no, I don't want you to focus on direct versus applied, but instead I want you to think about, okay, what disciplines should we give Australian research funding to? Now, what I'm going to do is give you some shaping here. So these are the FOR codes, fields of research codes. And as Mary has said in the chat there, nobody likes these, but these are important for the classification of research. Researchers all over Australia use these to say, okay, which field are you working in? Within this, there are 22 two-digit codes. So this is like the parent level code. So mathematical sciences is 01, physical sciences is 02. Stepping down, there are 4-digit codes. So they nest a little bit further, and then 6-digit codes. So for example, one little bit of quantum maths where you do something really obscure might be 01 for maths, and then 07, 14, something like that. So each piece of research ends up with this code. I don't want you to go down to all of those levels. I'm just explaining how precisely research is categorized. But what I'd like you to do is think about the 22-digit codes here, and think about, I thought I just changed that. Oh, I did. Okay. I have to change it here too. Okay. What I'm going to do is put you back into your groups, and I'll give you 20 minutes. Or do you want a coffee first? Okay, 25 minutes. Get yourselves a coffee. And then I want you to work out how are you going to divide your $10 billion into these 22 different fields of research. To do that, yeah, as Sean has said, it's you can just divide them that way. What I'm going to do is I'll make a Google spreadsheet, and I'll put the codes across the top, and you can put your groups there, and you can just work out what you want to do. I'll share it in the chat in a second. So grab a coffee for 5 minutes, and then we'll come back at, what does that make it? At 10 to 11, and then we'll go through the chat. But I'll put the, do you want, yep, well, I'll mix up the groups again, and we'll go from there. So grab a coffee. I'll put the link to the Google spreadsheet in the chat and return back at 11:50. You'll need to grab the, actually, I'll make the Google Doc before you leave, because you can't see it once you're in the, once you've gone to the breakout rooms. With the link. All right. Here's the Google spreadsheet. I'll start populating a little bit. Take a break for 5 minutes, come back at 10 to 11, or jump into your groups when you've had your coffee, and we'll go from there.
Can't see the link, Will.
Oh, there you go. That's why. Cut and paste fail. There you go. And I'll make stop share. And I'll make breakout rooms. Rooms are open. Okay, welcome back. How did you all go? Is it easy to allocate who should get the most money, or hard?
It is really hard, and this approach is a really crap way of doing it, in my opinion. Because it doesn't make any sense to do it by research area at all. You'd be much better off having a set of criteria. Plus, if I was a scientist, I'd just shoehorn my research into wherever the grant is. And we all done it.
Other people?
Yeah, there's too much overlap between the categories to really break it down so easily like this. And some of the research that would be done would cover or fall into multiple categories as well.
Yes. So that's actually a huge part of a huge aspect of the politics of science, as different FOR codes achieve different strategic importance at university level or at government level. Different researchers will definitely go, oh, we'll squeak into this one, or we'll squeak into that one. We're involved in a project right now to see if we can use machine learning to code up research in terms of FOR codes. And one of the interesting things is you can do the simple version of that, fairly simplistically. But the challenge is that universities say, yeah, but we want to squeak this into here. We want to squeak this into here. Harley. Sorry, someone was going to say. Anyway.
Oh, I guess I was also going to say our group kind of noticed that if you think about the science, technology, engineering, mathematics, 3 of those were their own sort of classes. So technology, engineering, which was also questionable as what's the difference? And then mathematics, and then science is broken into a million different ones.
Yeah, absolutely.
Where none of the others were.
Yeah. Absolutely. Harley.
Yeah, I also just think it's kind of difficult to know, is 100 million in one area the same benefit in another area? Because there might be more costs on wages, some might actually have materials and buildings costs. So maybe to achieve the same level of research output, you actually need to put more into something just because it's inherently more costly.
Yeah, an important point there. So there's 2 ways that researchers, research decision makers, politicians can think about where they give the money. And you would have grappled with some of these straight away. One of them is, of course, in terms of the value they provide to society, and that is a crucial thing that everyone should think about. The other one is how much it costs to do research. It clearly costs. If you're a physicist, you look at the Large Hadron Collider. To do some types of research, you need huge pieces of equipment. Now, obviously, that comes with a society articulating a value of that research, but it costs many billions of dollars to do some types of research. I don't think I can imagine a law and legal studies or philosophy equivalent of the Large Hadron Collider. If you were to talk to a philosopher and say, okay, here's $1 billion for research funding, many of them would say, I can't think of very much more other than give me time. Yeah, they might say, okay, give me some research assistance or something like that. But there's probably no equipment that philosophers need. So on a paper by paper level, some types of research is just inherently more expensive because you need reagents and equipment. Others you don't. Sean?
Yeah, just on that, because I wanted to play devil's advocate for Gina Reinhardt, because as much as we do turn with cynicism at what the motivations for certain people, research in something like mining, which is one of the primary industries of Australia, where we get a lot of revenue from it, is something that needs to happen from an environmental point of view and so on. So there is kind of this clash of going, oh, do we want to research that? And yet at the same time, we kind of do.
Yeah, absolutely.
I would also say, though, as a primary industry, should it not be able to support itself and its own development?
A question to ask. Absolutely. So one thing I would say, and here's a great analogy. Well, firstly, when I give you some answers to this question, they're not going to be fulsome answers, because they will just be broken down in some of the research buckets, not all of the research buckets, but I'll give you some more information there. And so some of the research buckets that I won't be able to show data on is that business funded research. So we won't be able to cover that. Second one is one of the strongest arguments for the existence of government that even libertarians agree with is called the lighthouse problem. So the classic idea of the lighthouse problem is that you have a port and you have lots of different shipping companies coming in and out of that port. If they all put up their own individual lighthouses, they need a lighthouse, then that's a huge waste of money. Or if one company says, I need a lighthouse here, then every other company benefits. The best way to fund that lighthouse would be if all of the shipping companies using that port come together to fund the lighthouse that they all share in the benefit of, and they can all continue doing their own normal business. So government is the lighthouse in this sense, funded by all of the members of society to achieve outcomes for everyone there. Now, there are a variety of places where science can be like that. So, for example, CSIRO might do research on a new pest or something like that, a pest species, and all of the farmers who are suffering from that pest will benefit from that. So there are plenty of examples of industrial and agricultural types of research that groups of people coming together couldn't fund individually by themselves, but could fund if government is coming in there cooperatively. Ali.
Oh, sorry, I was just going to say that I think there's also, when thinking about the funding allocations, a level of you have to predict what's going to be important over the next few years. So for example, we rated the built environment quite high because I think post-pandemic, there's going to have to be a lot of research into how to restructure cities and things to kind of, because there's been always that push towards higher density. How can we then balance that with the needs of a pandemic society? So
great point. Now here's the question: whose job is it to work out what are the priorities for society 5 years from now, 10 years from now? Many would say that well, many would say that should be the job of politicians, to say, okay, this is what's happening, we've boiled this together, in 5 years we're going to need more built environment research or something like that. And part of their funding decisions are to attempt to predict the future, or at least to make the future in a certain light. So many will say, for example, nanotech or biotech, there's huge new growth in these industries, so we should invest in this, and in 10 years time Australia has this great industry here. Governments around the world will do that. The problem is when they half do it and then they pull out again afterwards. Sarah.
Yeah, I just had another point when we were making our decisions on where to put funding. It was interesting to think about the sort of emerging issues that those sort of sectors were looking at, especially sort of data is becoming a really big one. So like data governance and storage and things like that is a really big one. And it's hard to tell how much money it would take. And I think that's a really interesting thing to think about, and who decides those things.
Absolutely. Yeah, great point. Alyssa?
Yeah, I just had a little comment about the future thing because I actually have a friend who works in like developing futures. Like her job is to just sit and think and talk to other thinkers about what all the potential futures that might actually happen. And so when COVID hit, she was actually kind of creepily excited because she's like, oh, we thought about this, and like now we actually get to run the simulation. It was a bit creepy, but that's her job. Like, she thinks about futures and just all the possibilities of what a city might endure.
Look, I think, Alyssa, anyone that is interested in society would have to see a huge, not upside, but interest in COVID, because it's a great example of, okay, what underpins societies? What are the fractures? What could we do to have a better world? What might a better world look like? It is a huge living experiment.
Totally. The other thing I was going to say more about what we talked about in our group was, I'm sorry if this has already come up, but like, sure, you can allocate to these different sectors, but how do you even know what's actually going to get funding in the end? Where that money's going to go?
Yep, absolutely. So we will come to that in a bit. And Sarah, do you have a?
Sorry, I think I left my hand up.
No, not a worry then. And Helen?
Oh, sorry, I thought I was behind Alyssa, and then I realised she'd just gone.
No,
yeah, I guess the thing is, right, is that when you try to allocate funding to different categories, you have the whole problem of where do you put new stuff? Where does the blue sky sort of research fit into those categories, the stuff that you might not realise are emerging scientific fields? Because the ABS, they like to upgrade their classifications and definitions every so often, right? But sometimes you get a whole new field pop up that you didn't know existed before. Like at some point in the past, gene technology popped up.
Yeah.
And we didn't really have anything on it, and you wouldn't have known looking forward how much to try to allocate to it or how important it was. So sometimes you sort of need a bucket of other to put some stuff into for like emergencies or new emerging fields that they're coming up is really important, that sort of stuff.
A lot of, if we were to get down to the micro detail of funding agencies and funding regimes, a lot of people put a lot of value in small seed buckets that, say, for example, vice chancellors or the director of CSIRO, they might be able to put into different things to be more agile. If you can move little bits of money around more quickly, then you can do a small pilot project in something that then later you can go on to the bigger funded money. Now, one of the big critiques of what I'm going to show you in a second is that so many of the projects that are funded are often more conservative than government wants. So there is a large effort around the world to attempt to make the science that they fund a little bit more risk oriented. But that's a hard thing to do. So I'll show you why in a second. So firstly, I just want to share screens. You've already obviously seen the spreadsheet, but I'll just talk through a few things here that jump out to me. Now, the first couple of things, now, unfortunately, I can't do, if I had told you to just put it in dollar terms or just put it in percentage, we could have done an average. But I can see, you've got a fairly consistent coverage here of different amounts. Very few actually jump out fairly high. Like one group put medical and health research at 28%, but a lot of you are putting it at about 10%, 6%, something like that. A lot of you are putting history and archaeology and philosophy and religious studies down at 1%. So there's a bit of a leaning there. And a lot of you are putting a lot of things in the middle. So let's jump and have a look at how the Australian government has done that in the past. So again, as I said before, I don't have the funding for business research in this bucket. So this is just looking at the Australian Research Council and the National Health and Medical Research Council over a number of years. Now, the first thing to observe about this is that the National Health and Medical Research Council is in this graph around 600 million, and the ARC fluctuates between $1 billion and 300 million, but in the same sort of amount. But the first thing to notice there is that if both of these buckets are roughly the same size, what we're saying here is that health and medical research is roughly equivalent to all other research. So we fund health vastly more than any other form of research, health and medical research. And so in fact, even within the ARC, you'll see there's still up to 126 million, up to 10, 12% of the funding in the ARC is still in medical and health research. So you'll see somewhere between 40 and 60% of Australia's competitive research funding landscape is for medical and health research. Then if we look at some of the other ones, we certainly see, so take for example 2014, mainly because I can do the maths more easily. Mathematical science, 5%. Physical sciences, 7%. Chem, 7%. These are all in the mix there. Biology gets up to 14%. Then we go down to some of the social studies, and we're looking at studies in human society, 6%, but education, 1%, economics, 1%, philosophy and religious studies, 7%. Overwhelmingly around the world, governments fund medical research, A, because there are industries, and B, because it is probably what society is super keen on. People very much like the idea of funding cures for cancer, cures for other diseases. Now, even within that, there's huge debate about which diseases we fund, what approaches we fund. You'll see a lot of public health researchers say, hang on, you know, if you spend $1 in public health research, the outcomes are, don't quote me on this number, you know, $10 for every dollar, versus every dollar you spend in pharmaceutical development, you get a return of less than that. So there are still politics within that, but we fund enormously in the medical and health spaces. So what I wanted to turn to next is what research deserves funding. And this is the sort of thing that you were just talking about. How do you decide, not only at the field of research level, but how do you decide between this project or that project, what deserves funding? Now, each funding body will look at slightly different criteria and will always be evolving their criteria, but they tend to use a version of something like this. So the sorts of things, and the NHMRC and the ARC both actually use literal percentages here to try and work out how these all balance together. The first category is the quality of the researcher. So this is, can they deliver? You know, do they have a track record? If they're a professor and they've got 100 papers, then surely that speaks to the money more likely to go to a good home than a brand new researcher who's only got 2 papers. That makes sense. It makes sense to give money to people that are more likely to achieve an outcome, but what's the downside of that?
The same people with funding.
Yep, in both more of the same in types of projects and more of the same in types of people. So inherently, research funding has a problem of, it's called is it the Peter problem or the Paul problem? I never remember. Rich get richer. So if you have been funded, then you are more likely to be funded again. For the researchers themselves, that's fine. For the researchers who haven't got it, that's really frustrating. But for society, there are positives in the sense that you're likely to get outcomes, but there are conservative elements to that. It means that other research projects and other ideas don't get up, and that is a big problem for science. The next part, and again, this might be, you can, I don't have the exact percentages, but all of these come into the mix. It might be 25% each or something like that. But the next one is the quality of the institution. So the same professor at University of Melbourne, ANU, University of Queensland, University of Sydney versus a more regional university. This seems unfair, but the research agencies will say if you're in a university that has a higher track record, better institution around you, then you're more likely to deliver. Again, that's one of those things that is conservative and safe in the sense of, okay, we spend $1 million on this. The Australian taxpayers want value for that. But it also means the rich get richer again. That list there, Simon, is that from the ARC or from...
No, that was just from your spreadsheet. I just typed it in.
Yeah. okay. The next category is the project itself, which this is what you might think of. Surely that's the dominant thing. That's the idea. That's the, you know, what are you setting out to do? Typically only counts for about 25% of the merit attached to that project. I don't know how to feel about that, because surely it should be about the project, but there are other priorities. Then the final one is the national research priorities. That's government stepping in and saying, okay, how do we give that money? If we want to give money to astronomy or agriculture or something like that, they will shift funding in different sorts of ways. Both of these, in both of these, both applied research and blue sky research do form a part of this. So blue sky research can be funded based on all of these. And in fact, our national research priorities, much as we might castigate government as Luddites who don't think about the big picture, we definitely do fund curiosity-driven research, and part of our national research priorities include doing stuff that is very esoteric and curiosity-driven. So what I just wanted to talk through just for a second is one of the differences between blue sky research and applied research, and how we start thinking about them. Now, you don't need to read these out here, but the blue sky research can be not oriented to the problems society focuses on. Curiosity driven can be very esoteric sounding. But if we look at both of these projects, so these are two projects that were both funded in the ARC a couple of years ago. Both can sound quite esoteric and not oriented towards the rest of society. Rain has just put the science and research priorities, current science and research priorities there in the chat. But, and this is something that I hope all science communicators pay attention to, there is a bit of a political discourse around blue sky research. And it can be quite a negative one if they are not framed in the useful way. Yes, Ruby, we'll definitely come to that. So there's actually quite a movement in a number of countries. You see this a lot in the US, but you definitely see it here in Australia, of politicians attacking the funding of blue sky curiosity-driven research, or research that doesn't sound like it has societal outcomes in mind first and foremost. So, you know, you see classic examples of this. Feds spend $300K on study on how to ride bikes. Anyone think of how that might actually be useful? Again, that's probably a rhetorical question, but Andrew, you could answer that.
Well, it depends on the actual study itself. What were they looking to find from this? Was it to do anything to do with car problems in the USA as well? There's a lot of car congestion. Look at
absolutely
California and all the freeways they've had there, and that being on an earthquake on the fault line. So there's a lot of different ways this could potentially be beneficial to society. So Fox News has used, you know, the spending as a way to attack the potential science. So it's a matter of just sort of what the results of the data are, and then go from there. But anyway,
absolutely. So what I would be surprised if scientists are actually proposing things without some clear value for science and research or for society. But yes, there is a strong political discourse against this kind of stuff. Some other examples. This is a couple of years ago, Republicans in the US wanted to cut funding entirely for political science. And again, and as I think we'll come to in a second, they often say, we need to fund other research that will save lives. So pitting researchers against each other is a political discourse that a lot will follow. Daily Telegraph can reveal the list of types of grants that would no longer be funded under new and more stringent guidelines for the ARC, including an RMIT project on spatial dialogues, public art and climate change, which sought to explore how people could adapt to climate change through public art. Might be quite important. Coalition sources also cited as waste several grants worth more than $1 million into philosophical studies, including the meaning of I through a retrospective study of 18th and 19th century German existentialists. I mean, that's curiosity-driven research, but surely we should fund as a society things that make us better able to think about ourselves. One thing I would say, we may be in the sciences right now, and many of you, I'm not actually. I'm going to be explicit here and articulate this is my value, and you can take your own values here, and I'm not attempting to change your values, except to articulate that we in the sciences would do well to stand up for all forms of curiosity-driven research, because if we allow politicians to attack curiosity-driven research over there that is funded, and we stand back and say, oh yeah, that's all right, that's philosophers. You know, first they came for the philosophers. We've got to be careful of allowing that. $160,000 given to Macquarie University to examine sexuality and Islamic interpretations of reproductive health technologies in Egypt. I mean, that's actually really important. I mean, even from a prosaic applied sense, rather than from a curiosity-driven sense, you know, how we think about reproductive health makes a big difference to population of the planet and population of women and children. So yeah, this is what I was saying before. So often there'll be a bait and switch. I just want to give money to cancer research. You know, what I really want to do is make sure that our bucket is correct. However, what it ends up being so often is an attack on all research, and there is a loss of all research dollars. And I haven't quite shown it in the budget figures here, but that $10 billion that Australia spends on research has not really gone up in the last decade, which means it's gone down in real terms. Sarah.
I just wanted to ask, has that number not gone up? Has there been more funding outside of government, or is it just we're not bothered to change it?
The funding outside government, so the stuff that isn't tracked at all. So for example, a company spends money to do research. If that doesn't show up in their tax return, then we don't know what they're doing. But I doubt that's changing. So I think in general, the number is not actually changing, which means we're spending less and less as a society each year in terms of our research dollars. Now, probably what happens is you get, in Australia, the Labor governments are likely to spend more. And so you get a sort of a sawtooth effect. Labor will go up, and then Liberal will go down, then Labor will go up a bit higher and go down. But it's certainly not, you know, tracking against GDP directly. Now, what I'd raise, and I think, let me see who put it in here before. I have to scroll back too far to find out who put it in here. Someone put something about Einstein. But what I just want to raise is a useful argument for all those who say, Ruby, it was you. I thought it was you, Ruby. All those who would say that curiosity-driven research doesn't lead anywhere. And the classic example is Einstein. So Einstein's work was mostly at the turn of the 20th century until the 1930s, but he won his Nobel Prize for work that he did in 1905. Special relativity was in the 1910s, general relativity in the 1920s. But the key thing here is that we can't use GPS without Einsteinian relativity. GPS wouldn't work without Einstein's theories. He was working purely for curiosity. He was trying to understand, okay, what is the shape of the universe? How does time and energy and movement and space work? And we've been able to operationalize that first about 40 years ago by the military in terms of global positioning systems, but now everyone has GPS devices all around them, and we use them more and more and more. And I'm sure if you were to do a study looking at the value of GPS to the global economy, it would be in the many, many billions of dollars. Now, Einstein didn't set out to do that, but curiosity-driven research opens up new ways of thinking about the world that can lead to huge benefits for society. Even beyond that, though, Einstein trained a lot of junior researchers under him. And those researchers went on to do good things in physics and maths, and they had a huge impact on society. So even if curiosity-driven research itself never leads to anything applied for society, then having people that are smarter and trained up to be able to look at complicated problems itself does lead to key benefits for society. So curiosity-driven research is an enormous value that I think we should all defend as much as possible. Because as someone said there, first they came for the mathematicians and I said nothing. So here's what I want you to think about in the future. How should we balance our research funding? And I don't mean that, as I asked before, just in terms of discipline. Instead, what I want you to think about is how should we balance our research funding in terms of how conservative or how risk-oriented we are, how blue sky versus how applied we should be, how much we should fund young researchers versus old researchers, how much we should fund a diverse pool of researchers coming in versus the same old people having the same old answers to everything. Because government buys research, and the types of outcomes we get for society depend on what government buys. And I think it's a key thing for us involved in the sciences to say, well, if we buy research that looks like this, then we're going to get outcomes that look like that. But what should we do differently? And I will leave it there. Does anyone have any questions or comments or things that they think we should be doing?
I was just thinking there's a magazine that NASA publishes called Spin-Off, and it's basically I guess almost a PR thing. So it has all of the things that NASA has developed for space reasons that have then gone on to be used in everyday life. So things like memory foam were developed by NASA. And then obviously they're used now in mattresses, in hospital settings, in loads and loads of places. And it's almost a way to retroactively judge the funding and go, look, just because this isn't how we meant to use it doesn't mean it didn't have value to everyone else.
Absolutely. And here's NASA knowing that their budget is always under threat, as much as they can demonstrate that they have their curiosity-driven research has led to outcomes for society, is a massive thing they need to do. Similarly, CSIRO does this a lot. They're always trying to articulate their impact and their value. In fact, this is a big part of much research funding now. It's called the impact agenda. As scientists and science are asked to demonstrate their impact to society, this is a key thing. More and more science communicators are now employed to tell the stories of impact of different research. Zulika.
Yeah, just talking about impact, my partner he's got a PhD in machine learning, and he recently published a paper where he had to describe a broader impact statement at the beginning of the paper. Very theoretical, highly maths-based machine learning, zero broader impact. But now a lot of journals are forcing theoretical people to do that as well.
Yeah. Journals are part of this as well. I mean, as much as we may have seen the height of, look, curiosity-driven research doesn't mean that we can't talk about impact. I think impact is a way of saying, how have I benefited someone out there? If it's just about the field and we've got a new method, then that's great. But what else might it be? How might it be used by other people? And so many scientists are trying to capture impact and tell stories about it. Any other questions? Any other comments before we go? Because you don't have
Well,
to hang around.
I was just wondering if you've got any ideas, if there's anyone around the world who's doing this in a different way, that's a more creative way, a better way of working out how to fund things. I mean, the old way was just to give people buckets of money and hope research comes out the other end. And that wasn't very good. And now it's down to so much detail that everything is in a straitjacket. That doesn't seem very good. Has anybody got any great ideas? I don't personally, but maybe someone else has come up with something.
So there are ideas around. Occasional things that I see are randomization of grants. So what they instead say is, okay, 100 people, and this is a consistent problem for us, is that 100 people apply to the ARC or whatever. And of those, you probably get 10 that are outstanding. And they're like, wow, that's great. But then you get like 80, at least 80 that are great, that would do really well. And then there's probably 10 at the bottom that are like, oh, what's going on here? The problem is, if you can fund 15 of them, then hopefully you get the 10 who are great get their money. Hopefully, it's not always that simple. And then you pick 5 almost at random out of that other 80 bucket. They're all decent. They all should be in the mix. It's very hard to draw the line. And so there are some people moving around and say, let's be explicit about that. And let's literally move to a more random funding pool, where we just say, if you make a certain criteria, it's going to be random in there because we can't tell the difference between all of you. The other way to do that as well that I've heard is particularly younger research, early career researchers, definitely putting in there and saying, okay, there's random seed funds for people. You get it this year, and then someone else might get it next year. I don't know. I think there's also there's a lot more movement towards linkage type funding. So the ARC has the linkage program, and then there's the cooperative research centers, where it's government saying, okay, if you can demonstrate a partner, so a company or a government department or something who wants this, and they put in some money, then we'll put in the other side of that money as well. And that's a way of reducing risk for government because someone else wants that result. Victoria.
Yeah, I was just going to say, the company that I work for, lots of the scientists work in research, pharmaceutical research, but also split their time with university work as well. And but the organisation gives them. I've just done some comments on it actually, like a day a week to just do blue sky research, just do what you want to do. We won't expect outcomes. You tell us what you're going to research, and we'll give you the time and the freedom and the resources to do that. And I think there's a number of companies that do that, and that's so liberating. One of the scientists I talked to said, I just feel trusted and liberated, and it's a great way to promote that freedom of thinking.
Yeah, absolutely.
I know it's a luxury, but
I've heard, and yeah, not all companies can do it, but I've heard amazing stories out of those sorts of processes. I think Google, I don't know if Google still do it, but they certainly did in the past have that one day a week. You can donate to your own projects. And I think Google Maps was something that came out of that. Is one of those classic stories of someone said, oh, we can just do that. Then it turns into a huge, I don't know if Google Maps raises money, but a huge aspect of Google's profile. So it certainly raises value. And I think that's an enlightened form. And so what I would say there is that's a blending of probably 4 days a week that person is working on more directed, applied sorts of projects, but then allowing curiosity in other spaces might be a really beneficial thing. Sarah.
Yeah, I just wanted to ask a question because I'm not really sure how to go about answering it for myself. Mm-hmm. When you see change in science, how do you know where it's come from? Because a lot of the things a couple of people said about the FOR codes was, well, we had an FOR code just pop up, but it's a long time coming. How do you mean
change in the bureaucratic organizational science, or how science as a whole changes its mind?
Both. And all of that.
So they're two very different answers. How science as a whole changes its mind is a fascinating question. So the classical theory from Karl Popper is falsification. So eventually, a piece of evidence will emerge. We've got theory A. A piece of evidence emerges that says theory A can't hold anymore, and so all scientists abandon theory A and move to theory B that can now withstand that new piece of evidence. This is not true at all. In practice, people, the defenders of theory A will call theory B fake news and declare that it's all whatever, and it will be a long political fight within sciences to change their mind. So this is Thomas Kuhn's approach to the structure of scientific revolutions. So what he's arguing is mostly science changes by having old scientists die out. And the new scientists will agree to the new theory that is backed up, but mostly scientists are like most people. They don't change their mind just because there is new evidence. But then we never do. We only change our mind when there is a volume of evidence. How things change bureaucratically, it's an ongoing conversation between Australia's scientists, their peak advocacy bodies like the Academy of Science and the Department of Science to say, oh, we should probably, nanotech's getting more important. Does nanotech need its own FOR code? And people will change that. Every few years, there'll be new FOR codes. So for example, science communication doesn't really have an FOR code. Some members of some science communicators will say, we really need one. Others will say, I don't know, we fit in somewhere. What does it really matter? To be classifiable is to exist in some definitions. If you can't be seen by government forms, then you don't really exist. If you can be seen by government forms, then you exist and you can be tracked. And so a lot of political debate will come into trying to get into government forms. I'm going to do the history of forms one day. So interesting. Belinda.
Hey, yeah, Will, I've just got a question. I've just been thinking about, you're talking about, sorry, trucks going past, about the randomization, the possibility of randomizing the way that research is selected, and these concepts of, things being conservative because we keep on funding the same people. And I'm just wondering if it's just a factor of us being human and wanting to have job security. It's almost like, we're looking at this as a conceptual issue where we can just adapt to any situation, but is part of this drive to select science on that basis because people can't just, survive with 3 years of funding and then no job. Is the industrial relations side of it, that kind of job security, human aspect of it, part of the why we do it that way?
Oh, look, absolutely it is. It really is. I mean, you could flip it up and have a highly risk-oriented and changeable scientific landscape, but then you would lose a lot in terms of the human capital. We really do. That's a huge thing that governments need to pay attention to is keeping a scientific workforce and funding a scientific workforce into the future. So I guess the thing that an enlightened government, so take away the make it a government that really likes science, then they still need to think of a variety of different things in terms of predicting the risks of the future, predicting the industries of the future, developing our human capital here in Australia, smart scientists, solving particular problems for particular industries, raising new students. There's a whole bunch of things in there, and it's a really difficult thing to get that balance perfectly right. I think one of the big challenges is that as you set funding parameters, then everyone optimizes for those parameters. That's what people do. You're told what the goals are, and people orient towards those goals and they optimize for those goals. But those goals need to be up for debate. We need to, as a society, say, all right, how risk-oriented, how conservative, how careful, how open, how industry-focused, how curiosity-focused should we be? And I don't have the answer for that. And I don't think any one person has the answer for that. And we're always going to sort of move around there. But I think the first thing that's really important is to keep that open, that we shouldn't say, okay, Australia should always be at this sort of thing or that sort of thing. We should have an ongoing discussion about what sort of science we want to buy should be. Yeah, that's an interesting point there, Susie, about check out Malcolm Gladwell's podcast episode on using lottery for elections. So this is a process. We're trying to get something up in climate change, but COVID killed it, called sortition. So instead of choosing your elected representatives, you just randomly select 100 people from society to come together and solve a particular problem. Supposedly, the arguments are that they take it very seriously, and mostly you get much better outcomes than people who are professional politicians. Could you do this in science? Probably. Did you want to flesh that out, Susie?
Well, my memory of the specific researcher that Malcolm Gladwell interviews, so I don't know if this is like across this whole field or not. I don't even know how big the field is looking into like using lotteries in this way. But the piece of it that I thought was interesting was the research has mostly been done with electing student councils in like high schools. And what they do is they have the students that are, eligible in the sense that they're in the right age range. They fit the criteria, they're 17 or whatever. Anybody who wants to put their name in can. So there's one step where you determine your level of interest. So not everyone may put their name in the hat. And then that's when the lottery starts. So it's not everyone that fits the criteria, which is that they're the right age or whatever. They also have to stipulate that they're interested. And what they found is that lotteries are actually a better system in this context. They haven't scaled it up. No one's tried it, as far as I'm aware, at a higher level. But yeah, it's interesting. Yeah, exactly, Mia. It's that opt-in. So it's not everyone. It's everyone who has said they're interested.
So there have been a few interesting examples. So there was a citizen jury in South Australia a year or two ago on a nuclear waste dump. There's been a few that have done things. The UK one ran one on climate change recently. So what they typically are is they're bounded. Sometimes it is we'll recommend a policy. Sometimes we'll enact a policy. You could enact a policy at lower levels, but governments at the moment aren't allowing people to just get that far. But often what you see is a really strong engagement with opening up different disciplines, opening up different questions. If we go back to the stuff we were talking about at the beginning, a citizen jury can be a great process of then engaging with science arbiters and saying, okay, we've got heaps of questions. We want to know about this. We want to know about that. Can you provide more information here? What they're trying to do in all of these lottery processes is get away from inherent conservatism in decision-making bodies. But there's an element to which conservatism is important. So yeah, well worth a listen, well worth a look. Any other questions or comments? As Mia says, yes, relative to opportunity, very important to think about how that impacts diversity. Relative to opportunity is a way of tweaking it so that it's not just the professors who look like certain people. Simon.
Yeah, I'm just debating whether to ask a question or not. I was just really, I think the optimizing for outcomes that you just mentioned before kind of really spoke to me about my time in corporate world about KPIs driving behaviors. Mm-hmm. And I was just kind of interested, like the example of like the laser was a pure science research activity, and then it had this incredible application. I mean, has there been like dedicated, detailed research on the circumstances that produce that? And is that part of the modeling of setting up the same sort of situations going forward to allow for those possibilities?
Do you mean setting up certain sorts of labs, or setting up the laser lab?
I suppose I'm sort of coming at it a bit from what we've been doing in public as well, is like understanding the behaviours to get these outcomes. Like if people looked at like, okay, so this was the situation that produced this laser technology, this was the government, this was the society, this was the time, this was the investment. Can we replicate this to get the same results?
So there's a bunch of discourses here that are really interesting. There are people that study labs and try and understand when are they successful and why they're successful. So why, for example, is the Cavendish lab in Cambridge, Oxford? Why did they produce so many Nobel Prizes between 1900 and 1950? Why did they do such great physics research? Or other people that are looking at, okay, how do we duplicate the Silicon Valley model of university to startup to huge tech giant? Governments around the world are trying to do these things, trying to say, okay, what do we need to duplicate about them? Now, the interesting thing is there's a lot of complicating factors. Okay, for Cavendish Lab or Silicon Valley, what are the things? They're going to be a little bit about the geography. Who's in the space already? A little bit about the policy regimes. You know, how quickly can we modify and change to different sorts of things? A little bit about the funding that's around. You know, Silicon Valley is partly Silicon Valley because there's venture capitalists there, and venture capitalists are able to spend money in different sorts of ways. So even while there is people trying to replicate these things, you don't often find instant replication at all, because there's weird bits like culture. So it's not as easily replicable as governments might want.
Yeah, I suppose, and also the example there about Google having the 1 day a week to do pure research. I mean, that in a sense is following a model where whether it's explicitly been said is like, we're going to allow these smart people to just do whatever they want, but there's still competition involved, and there's still kind of there's all these resources made available. So that's like a model which is working in the private sector. Is that something that can be applied to the public sector?
Well, what would it be? I mean, can you imagine the political discourse if government bureaucrats were allowed to spend 1 day doing whatever they want on taxpayer dime? Can you imagine the right-wing papers and how they would react to that?
Yeah.
The corporate world has more freedom on these things than the government-funded world. Whilst, you know, when it comes down to it, university researchers, you might say, have way more than 1 day a week to spend on their own thing, or way less, depending on how it actually works out in practice. Any more? Cool. See you next week, everybody.
Thanks, Will.
Thank you.
Thanks, Will.
Thanks.